virtual tour. A little brief introduction. You know who I am. I'm the president and CEO of Mid-Mountain. It was founded by my father, one-man show. We were working in the garage, making parts, and a lot of companies start in garages. We did too, and I've pretty much been working for Mid-Mountain all of my life. I did have a number of other jobs through high school, but you know, I'm in my 44th year since we incorporated. I actually started in 1967 in the garage when I was 7 years old, working with ceramic fibers. Ceramic fibers are a very high temperature. They were new product back then, and a substitute to asbestos. Mid-Mountain was selling mostly, or my father was selling refractories to the steel industry in Pittsburgh and also in Toronto. And asbestos seals were getting a lot of attention as a bad thing, a health hazard. So my father started making seals in the garage out of this ceramic fiber, and I started helping him. They were specialty products, commanded high margins, and eventually a company was born, and it was incorporated in 1976. As Kirk mentioned, my sister Gretchen and I are partners and run the company. I have one of my sons, Jacob Knapp, working for the company in operations support, and he's doing all kinds of things in administration as well as in the plant. So we've got 3 generations. Proud to be a family business, and I guess I'll start showing you what we do. A lot of our products have become commodities over the years, and we compete with China with a lot of fiberglass products. You'll see those in just a few minutes. And one of our focuses is to convert the company back to a specialty products company with much higher margins than what we can get on some of these fiberglass textiles, silica textiles, and so on. So I'm going to first show you a piece of fabric that I'll talk more about later. I'm going to switch my screen. I just want you to see this roll of fabric. It's sort of greenish in color. It's just a dye. This is a ceramic fabric. It's one of our new projects. We'll be weaving these fabrics. We'll also be drawing the yarn. We'll be making the yarn out of a silica alumina sol gel. You make the sol gel using nanoparticles of those 2 materials and aluminum. And it's a water-based system with a little bit of a solvent in it. And you extrude the fibers. Oh yeah, here's my desk. A couple of things that I believe in. It can be done, and we do epic stuff around here. I'm going to mask up, and then we're going to go out into the plant, and I'll talk more about that ceramic fiber in just a minute. Okay. First, I'm going to take you into a laboratory where we make a lot of our coatings, refractory products. This is where a lot of the R&D takes place. We have a number of ovens for doing shrinkage testing, curing of products. I don't see any ceramic fiber to show you right here, but we have some around somewhere. We have a lot of chemicals. Mid-Mountain is mostly solvent-free. We do have some cleaning solvents and light solvents, but everything is 100% solids or 2-part catalyst cured materials or water-based. And we don't put anything down drains. We're very environmental. This is another lab. We sell a lot to the fireplace industry. We actually made the material that they cast this firebox out of. It's a ceramic material, also the burner. This is a material that's ceramic, but you can drill holes in it and put screws into it like wood. So it's a very unique material and it's insulating. We also make a seal that goes around the window. You can maybe see it down in here. I'll show it to you when it's being made. But if you have a gas fireplace in your home, it probably has a lot of our materials in it. This is a coating head for round and square textiles and our vertical coater. You'll see that. We're going to start in the coating department. Can everybody hear me okay?
Yes.
Okay, thank you.
Yes, John, we're hearing you well.
Okay. This is, whoops, sorry, this coater line 5. We have 3 horizontal coaters, 4 horizontal coaters, 3 for wide goods, 1 for narrow. This is a machine that does the dip and squeeze. We're putting a refractory coating on a fiberglass fabric that we wove. And this is coming out of the oven. It's winding up over there. There are a lot of lamination stations. We can laminate adhesives or films to the fabrics on this end of the machine. This is the vertical coater for narrow goods. So we produce this fiberglass rope, and it's going through a coating process, goes up, gets cured. That's a Harley Davidson drive wheel, by the way. One thing we do at Mid-Mountain is we built this piece of equipment. We did it in a hurry. We needed a wheel, so we went to a motorcycle shop and got one and motorized it. Anyway, this is a silicone-coated fiberglass rope that's used as a crucible lid seal in aluminum smelters. We sell this all over the world. This one's actually going to Indiana, though. This is the dip and squeeze process. Putting this refractory coating on a fiberglass fabric that makes it higher temperature resistant. It's a 2,000 degree coating on a 1,000 degree Fahrenheit fabric. That'll take one-sided heat up to 2,000 and a soaking heat the glass will melt. It's also very abrasion resistant and reduces the permeability. It's normally used in the aluminum smelters around the world to seal up the aluminum pot lines and keep all of the hazardous gases, hydrofluoric acid gas, that's what it is, in the pots along with all the dust. So the pot rooms are cleaner and it all goes through the scrubbing system so they aren't polluting. As you can see, it's a pretty big machine. They take a little bit of experience to learn how to run. All of our operators are going through formal training for a couple of months before they're allowed to operate a machine on their own. I guess we're going to go over to the textile department right now. I'll go back to coating later. This is a loom that weaves this fabric that you just saw getting coated. It's unfortunately broken down. It broke down on Friday, and parts are coming from Germany. They're 9 to 10 weeks out, so we're looking at a quicker fix. We're talking to some 3D printers who 3D print metal so we can have some metal parts produced, put this thing back together and start running again. As you can see, there's about 3,500 balls of yarn behind that on creels. This is one way to weave. Another way to weave is on this particular loom. This is a brand new loom that just came in from Germany. And you put down on this end a big spool of yarn. It's called a creel. And that creel gets fed through, or the yarns get pulled through the creel and then through the, what will be here are the heddles, and then a reed, and then a fabric will wind up down underneath here. This is a mechanical, or excuse me, this one's an electronic loom, and the other one is mechanical. This it's all programmed, computerized. We're excited to get it running. We have some yarn on its way on a beam coming to us, and we're going to set up to run first a S2 glass, high strength, high temperature fiberglass in the same weave pattern as that green fabric that I showed you, that's ceramic. Once we have it dialed in with that, we're then going to load ceramic yarn that we are producing in our Chinese operation. I've started another company called SPS Technologies. SPS stands for Seattle, Paris, and Shanghai. We'll be producing the ceramic fiber in all 3 locations for Boeing, Comac, and Airbus. We'll be close to each aircraft company, and then these fabrics go into ceramic matrix composites. It's a new technology of composites that is replacing metal in jet engines. In fact, the LEAP engine is almost the Rolls-Royce LEAP that's on the 787, 737 MAX. There's very little metal in it. They're all white ceramic matrix composite parts and black silicon carbide composite parts. And they're lightweight, they're higher temperature, last longer than steel, and of course for the military they're stealth because they're not metal. So everybody wants this ceramic product, and it's in super high demand. Only one company on the planet makes it. They're sold out and have an 11-month lead time, so that's why I decided to go into that business. Anyway, here's Jim Duke, our lean coordinator and project manager. Jim has done a great job with our lean program, and he's going to explain to you a little bit about what he does. You're going to have to use this microphone.
Move around here.
There we go.
Good morning, camps. Like John said, Jim Duke, lean coordinator and also a project manager. I've been with the company 2.5 years, and I arrived here when we initially stood up the lean program, and so that since has grown to we have a kata board for each one of our 5 major departments, and the goal is every day we meet 15 minutes, and I go make the rounds. Takes me about an hour and 15 minutes each day. And then some time off the side, sometimes helping the improver with conducting experiments. Throughout the pandemic, we've kept this going with face-to-face meetings. This is obviously something that's not like in many manufacturing, cannot be done via distance. So I've been here on site every day, taking the appropriate precautions and keeping the carry on our kata boards and lean program, and really help keep the continuous improvement going.
Thank you, Jim. Um, okay, I'm gonna take us back over into the coating department. This is what we call a tadpole tape. It's that black seal I showed you in the fireplace in that one lab. It's coming off of this master's school, going through a spray system. It's kind of a mess. And it goes through a horizontal oven. And we're applying a pressure sensitive adhesive on it right here. And then it's just falling onto a pallet. We do have a lot of plans for, I guess, eliminating certain steps in this process. Right now, we need a winder right here where it's being wound and packaged, wound, inspected, and packaged at this location rather than another location in the plant. There's so many opportunities, low-hanging fruit in our factory, and probably in most. You can't get to all projects at once, so we're doing the most important ones first. This is another coating machine that is having some maintenance done on it right now. They're working on some burners over here, cleaning them and adjusting them. This is coder 4. This is just a production board for the coating department. And we have a meter mix dispenser. That's a dispensing nozzle you're looking at. We're looking at either a cobot or linear motion to replace an operator that would be applying the silicone out of that meter mix dispenser with optical sensors, keeping the coating at the right volume on this coating machine. It's fairly old coating head. It works great. We developed the Airbag Fabric that everybody's using today. It's a kinder, softer, gentler airbag that doesn't hurt small people. We did that in the 90s, and we could coat 100 feet per minute for General Motors on this. That turned into a commodity business, so we left that alone. You run a lot of product, but you don't make very much money. This is an old re-rolling inspection machine that is being replaced. We have purchased a new re-rolling inspection machine and an automatic packaging machine from Italy, which will be going in this whole area. Here's a picture of the new machine, and it winds it up and pushes it sideways over into a packaging machine that, this might be the packaging machine, the re-roller might be over there. Once again, this is Jim Duke's project. Due to COVID, we were supposed to have this in April. It's $500,000 worth of equipment that was in the hardest hit part of Italy. Yeah, this is the inspection frame and re-roller, and it automatically will push the material into that other machine where it'll package it instead of us hand packaging in these plastic wrappers. I'll show you more of that. This is a lot of fabric that we've woven. It's all coated, or it's just queued up, ready to be coated. This is just a leader material they tie on to eliminate waste. And it'll all be getting coated over here on coater 4.
Hey, John,
Yeah.
we had a question come up from Aaron, and thank you for the question. You mentioned that a lot of your products are becoming commodities. Do you have any existing patents?
Yeah, we have 20 patents. Well, 14. I sold 6 of them to Schlumberger.
Okay.
And they're more on fabricated parts. I did have a patent on this fabric, which is used in the manufacture of neon sign. I had a U.S. and Canadian patent on those. They're long expired. I got those in the 80s. This machine was our first coating machine. Our first one was made out of wood. I made it out of plywood on a weekend, put some infrared heating elements in it. It looked just like this out of plywood, 8 feet long. And, we did that because the supplier let us down, and we had to get some silicone coated silica to a fabricator making an expansion joint for a paper mill shutdown on the 4th of July. And our supplier let us down, so that's how we got into the coating business. I built a coater on the weekend out of wood and had a hand crank on one end and pulled it through. And we then made one out of metal because we burned the wood one down twice. Then we extended the metal one. And this piece of machinery was supposed to be scrapped when we got coater 5, the blue one over there. But unfortunately, we had to use this one to make a high temperature, high strength fabric for the Mars 2020 rocket that launched a couple of weeks ago. It's for the lander. It's a Supersonic Decelerator fabric. It's a big airbag balloon. It's like a balloon parachute that it inflates. It slows the lander down from about Mach 5, and it's about 5,000 to 6,000 degrees C, but it's only for 10 to 20 seconds. So we had to keep this machine in case NASA JPL wanted more of that fabric. And we still make that neon sign fabric on it. So anyway, our patents are mostly on our fabricated items and some coated fabrics, but not too many coated fabrics. This is a interesting area. This is mixing, where we use actually these Hobart dough mixers that bakeries use, and we mix ceramic fiber moldables. We sold 8 40-foot containers of that to Aluminium Bahrain. They use it in their new pot line to seal up cathode bar seals in a smelter. So environmental application. This is ceramic fiber, bales of ceramic fiber. We make adhesives as well as these ceramic fiber moldables. Our factory is unique because we have so many different things going on, so many different kinds of equipment. We do a lot of R&D and product development. I'd love to have a factory with 400 machines of the same type in it, but you're not as flexible then. You can't do as many things. This is our textile department. This is knitting. You guys might have seen some of this stuff in the 70s, macrame cordage, many colors of polypropylene. This is wood stove, pellet stove, other industrial applications, seals in the doors. This is a Nomex sleeving. It's used in wiring harnesses on satellites. We make a lot of that. The little circular knitter.
we're looking to replace all of these 100-year-old machines. You know, we've had to make some electrical upgrades to them. They're flat knitters. They're actually sweater trim machines, and we make this basically gasketing, and it goes all into wood stoves, fireplaces. This is a Nomex cord. It's used as a lacing cord in insulation blankets to go around steam valves. We also work with, this is a carbon fiber. This is Kevlar, Nomex. But most of what we do is fiberglass. There's another large Nomex sleeve. I don't know what its application is. There's another cotta board for the Textile Department and air filtration. You know, we have to have very clean air and low fibers for the health and safety of everybody here. These are narrow fabric looms. They call it tape or webbing, and this is a Tadpole Tape. If you see a cross section, you'll understand why. It looks like a tadpole from a cross section. So we make millions of feet of this for the fireplace industry. Oh, here's, you can't really see the end. Well, they're all running pretty well today, it looks like. We're now going into the Fabrication Department. What time do we have, Kurt?
You're good. We've gone for 30 minutes. We've got another 30 minutes.
Okay. Well, before I go over here, I'll show you that Tadpole Tape gets transferred back over to this area for packaging. These are spools of it going to manufacturers. We've got crates of it. Here's the end. Well, we've got a sample of the white, lot numbers, and the black. We're only trying to coat the crown, so the rest doesn't need to be coated because it's not visible. But if you look from the end, you can see it's sort of a bulb and a tail. So it's called Tadpole Tape or bulb gasketing. And it gets spooled up here on a little spooling machine. A lot of our equipment is homemade because it's not commercially available, or it is for a lot of money. This is our Fabrication Department. This is how we started. We started fabricating insulation, thermal insulation barriers, seals, covers, blankets, in our garage for the steel industry and then for the aluminum industry. And now we're in all industries except for medical. We used to do a hand cutting on these tables. We still do some. Now we have a computerized automated cutting table. Looks like he's about to set up to cut some, I think these are spark curtains. The spark curtains go on rail maintenance of way equipment. They hang on the sides of the carriages and stop sparks that are being generated from grinding wheels that are grinding the rails to reprofile the rails when they lose their proper, I guess, profile due to the weight of the trains. And it's especially important on curves and switches and crossings, because if the rail is not properly shaped, they can have derailments, and it also provides better fuel efficiency when the rails fit the wheels the best. So there's less friction. So anyway, these spark curtains stop the sparks from the grinding wheels from shooting about 25 to 50 feet out from the side of the rail car. And they actually do start forest fires. We had one here about 20 years ago called the Great Grinder Fire. And I never knew why it was called the Grinder Fire, but it's because somebody didn't replace their spark curtains. So anyway, this is cutting out rectangular curtains and putting holes in them. And it's a big time saver. So you can see we have a lot of sewing machines. These are all parts for a small aircraft manufacturer. And they're, you know, insulation pieces with silica fabric that we coated, and then we laminated foil on this side on the silica fabric. There's a silica blanket insulation inside. These are all for that. A small aircraft firewall insulation blanket. So all those parts either go into certain areas here, or they go on to other parts of the firewall, over this, or other things that they have inside the engine compartment. This is a carbon composite. It's our mannequin, if you will, and we make quite a few of these for one aircraft company, and we have others coming to us for them now. Well, here we're sewing a tadpole tape with a fiberglass strip blanket. We fold fabric around it and stitch it. Then they'll trim the edge. This will get a nice finish on it. This is an industrial application, not a fireplace application. There's another spark blanket. This is a fabric that we coated. So we're very vertically integrated. You know, we weave fabrics and then we coat them, bring them back to our fabrication department, and you know, our inventory moves around through the plant. It allows us to be very competitive globally and compete with, say, a Kazakhstan company who's buying raw materials from China, and they're paying somebody $7 a day to produce a seal next to an aluminum smelter, and we can produce it here and sell it globally because we are vertically integrated. This is the cutout for, it's the center part. It's waste from one product we make, where there's a big oval, if you will, cut out, and it's used as a vacuum lifter for hot ingots in the aluminum plants when they're pulling them out of the aluminum molds. They're called sow sucker seals because they call those big aluminum ingots sows, like a pig. And then we take this waste and then we're die cutting some rectangles, as you see, with a hole in them, and those are going into the aluminum industry around cathode bars. That's the bar that carries the electricity into the melting pot to melt the refined alumina and turn it into aluminum. That's one part of a patented product that will have some other fabrics sewn onto it, and then one of our ceramic fiber moldables is used in conjunction with it to make a hermetic seal that prevents oxygen from coming in and oxidizing the carbon lining of the melting pot. And also, if there's a problem with the pot and aluminum's trying to leak out, prevents a catastrophic bleed out of the pot by freezing the aluminum and stopping it, because this fabric can take molten aluminum high temperature. So we're, I guess, working our way towards the warehouse, which is raw materials and finished goods. Oh, here's our back lot. We have 5.5 acres. And our building is 60,000 square feet. What I've shown you is 45,000 square feet, and back behind the fabrication department, you'll see some crates in an unlit area up on the racks. Those are all aircraft tooling for Boeing and Brazil Air and Airbus, Spirit. They're not ours. When we bought the building, they were a tenant. It was Northwest Composites, who became C&D Zodiac, who's now Safran Aerospace. They just store tooling forever and ever in case they ever need to make parts, because the aircraft manufacturers make them do that. And they do some honeycomb production manufacturing on the far end. They take up 15,000 square feet of our building. They're a good tenant. If we need the space, which we might very soon, we'll take it. So here's our coated fabrics. This silicone coated fiberglass mostly, how we package it and how we ship it. As I mentioned, we'll have an automatic packaging machine that'll be heat sealing the edges. It'll wrap the plastic around, heat seal it. Here we have labor where we're twisting up the plastic and putting metal twist ties on. And a person has to slide the plastic over the roll. So Mid-Mountain's focusing on aviation. We get the biggest bang for our buck. Coated fabrics is one of our largest areas. This silicone coated fabric, like the gray one, and this, I forget what color they call this. I don't know what I'd call that one, but that's going into the fracking in the center of the country. They've gone to environmental colors to hide the insulation and try and hide the plants, because they're just covered with insulation and insulation blankets. These are used in sewn insulation blankets that cover the steam valves and flanges. And they all used to be this aluminum color. And now everybody wants, we make all sorts of different camouflage colors. This is a different color than that one. I think they call that one mocha. Anyway, we try to keep most of our inventory in raw-based fabrics and chemicals, the coating materials and raw materials, fiberglass yarn. Keep it in raw material form because we make so many different things. You know, if you make it all one color, somebody's going to order another color. If you make one size product, somebody wants a different size. So most of our inventory is raw materials, and as you see, packaging, and well, then we convert it. That's pretty much what we do.
Hey, John.
Hold on here.
Yeah.
Trying to turn my lens around. There we go.
Good. Thank you. And I've got some other questions that were asked.
Okay.
One good question was, how many employees do you have there? That's a lot of space.
I think we have 28 here. We have another small manufacturing facility in Evansville, Indiana, that just does cutting and sewing. They have the cutting tables and sewing machines, and that's for the aluminum industry in North America and around the world.
Okay.
We have 48 employees total.
Okay.
The offices are, everybody's got their own office. Their doors are closed, and everybody's doing what they can to stay safe.
Yeah, that's pretty
Well,
cool.
I have to ask how you got to Evansville, Indiana. This is Joe Vandersnick, and that's my hometown.
Oh, wow.
Wow. So, yeah,
We have our international aluminum sales manager had a company there called Evansville Refractories. And let me try and prop this up here. He was a competitor, and we had a hard time competing with him. Remove this. Oops. How do I better leave that in. I don't know how to get on the speaker.
We can hear you good. We can hear you really well.
He was a competitor, and then he sold to a company called Pyrotech, who's our largest competitor globally. They have 200 salespeople. They're 200 million in sales, and they sell a lot of equipment that casts aluminum. But they also sell these soft refractory textiles, and they do cutting and sewing. They bought his company, dismantled it, and hired him on for a few years, and then he couldn't stand working for them and started a restaurant in Evansville, Indiana, known as the Jungle. I don't know if you've ever been there. It was there for about 12 years under Tony's ownership. Then he sold it, and he went back into the high temperature aluminum world and worked in New York. And then he wanted to work for us, so I hired him because I knew how tough he was to compete against. And he said, I really don't think I should be in Seattle. I should be next to the largest aluminum smelter in the United States, which is in Warwick, or it's the Warwick plant, but I think it's in another town. It's 10 minutes. Yeah. So he also can service Quebec quicker from Evansville than we can from Seattle. Seattle's pretty far away by truck to a lot of places. So that's how we ended up there. So yeah, we have another building in Georgetown. It's a relatively new building. It's metal and it's really pretty and artistic with high vaulted ceilings and floor to ceiling windows. And it's not what you think of when you think of Georgetown. We have a couple other tenants in that building, but we bought that a couple of years ago and moved our corporate offices from Mercer Island to Georgetown, South Seattle.
How many employees do you have in your Georgetown office?
10.
About 10 or so.
But we reduced the density to 5.
Yeah.
When I came back from Egypt and France, a couple-week trip in the end of February, beginning of March, I went into the office. That's when the coronavirus was really blowing up in Italy and France. And I went in and they said, what are you doing here? Get out of here. You've been all over the place. And, so they threw me out of my own building. They said, we want to work here, and if you come, we're going home. So I said, okay. I always worked from an airplane seat anyway.
Yeah. Man. Now, somebody asked a question, John, if you explained this new corporation you're forming. You called it the China operation. Is that 100% owned by Mid-Mountain, or are you?
No, it's 50%. There's 3 actual entities. 2 of them have been formed. SPS Technologies Shanghai Incorporated. That's formed, and the ownership there is myself, not Mid-Mountain. Myself and 2 Chinese partners. One of them has been a partner of mine since 1995. We had another business over there, and he has a couple of houses here in Seattle on the lake, and he's my brother, essentially. We call each other brothers. SPS Technologies Seattle LLC is 50% owned by myself and him. SPS Technologies Paris has not been set up. We have to get, we're just going into full production the end of August right now, this week, in Shanghai. And we will be bringing some of that fiber over here and weaving it. It'll be going into the ceramic matrix composites. in industrial applications in the US. Aerospace needs, especially defense, needs 100% US made materials. So Mid-Mountain is the distributor for the Americas. We will be starting to distribute the Chinese fiber and then get it approved by the main players in the CMC and also metal matrix composites and polymer matrix composites markets. We have some partners that are willing to make parts out of our fabrics and pre-preg them with a ceramic matrix and then form some parts. Once it's approved, we know it's good, and then we're going to copy the Shanghai plant and put that in this building, make our own sol gel, and then extrude our fiber. SPS will sell the fiber, yarn, roving to Mid-Mountain. Mid-Mountain will either sell it as is to other weavers and then also weave it and sell the woven fabric to the Americas and Europe until we start producing in Europe.
So this was on this product that you said was like 11 months backlog from this one producer. So
Yes.
you're jumping into this competitive, it's
Yes.
not really competitive space, but it's an
No.
opportunity space. Yeah.
Yeah, nobody's been able to do it. This one company in the 60s or maybe even late 50s got a government grant to develop this product, the ceramic fiber continuous filament product. And a lot of people have tried to get into that market since, and it's very, very difficult to produce. And if you're not producing your own raw material, the people who make the silicone alumina sol gels sell them for a very high price. That fabric I showed you sells for $750 a square yard, and it's 11 ounces per square yard. It's not as expensive as gold, but it's one of the most expensive fabrics. It's only $68 an ounce.
Jeez. Wow. I thought ink was a good market.
But it's a very expensive fabric, and it's made from dirt. So, we're basically, there's a very, very high margin on it. It doesn't cost anywhere near that to produce. It's the technology for the production of the sol gel and of the fiber extrusion process.
So this
it's not melted. It's a low temperature extrusion.
So Bishop asked, and this makes sense in terms of in light of your answer, but you mentioned before things are, many things you sell are commodity, but you're looking at innovative products like the one you just mentioned. But what do you see long-term opportunities for Mid-Mountain?
Well, there are a lot of opportunities with that product, and I have sold out 40 of the new looms in one 3-day trade show. People saying, we want to buy from you, and here's our volume. When can you give us a price and product? It'll take way too much time to, it takes almost a year to get a brand new loom built.
Oh, wow.
There's a lot of demand on them right now, so you're in the back of the line.
Oh, wow.
I am going to contract weave. I've lined up contract weavers that have the weaving capacity for the 40 metric tons of fiber I'll be able to produce on the first production line. And our sales are 10 million. They're supposed to be 12 this year, but COVID hit. We were on course after March at 1 million a month, but then we've slowed down. It's starting to pick back up. Aerospace, aluminum.
Yeah.
People aren't buying cars, so aluminum's not being produced, and
wow.
Everybody's cutting costs. Plants are being shut down around the world. Actually,
you're being caught.
There's an oversupply.
Okay.
Yeah.
John.
Oil and gas, all of our insulation products.
Oh man.
Yeah.
Oh, Matt Smith asked this question.
What'd you
That
say?
kind of goes along with what you're saying. He asked, in terms of product mix, what do you see as your product mix there from the Arlington plant by industry? How, what
We're
percentages are going to
we're
differ?
very diversified currently. We're 15% aerospace, 20% insulation, 20% hearth products, 20% aluminum.
Wow.
Miscellaneous makes up the difference. We're going to be about 80% aerospace or 95% aerospace because our sales in the next couple of years are going to go to 50, 100, 200 million and then up.
Wow.
With high margin specialty products that are going to be able to pay for the expansion. We'll continue to add looms and reduce the contract weaving, but I'll always be contract weaving. We can't weave it all.
Yeah.
We also can make another product with the Sol Gel, which is it's a aerogel material that is the world's lowest thermal conductivity material.
Oh wow.
I just got a international patent application rejection notice this morning on a high temperature version of aerogel. Aerogel's been around since I don't know when. I know Cabot Corp was making it in the 50s. Most people are using carriers that are lower than 300, polymers that are lower than 300 F. Most of them are less than 250. We have found a way to take some other polymers, increase their temperature resistance up to 1200 C or over 2000 F.
Wow.
Wow. We are trying to replace all of the fibers with this aerogel product, and I'm trying to capture that market with patents first. I am very afraid that, as all of us business owners and anybody listening to their quality manager and understand ISO know that risk is a daily practice, risk analysis of everything that you're doing and every new thing that you're going to do, or what could happen. The asbestos industry was caught off guard, and I'm afraid that the fiberglass industry will be as well, and that history is going to repeat itself with fiberglass. That's a great concern to me because fiberglass is in most of our products, and if it's not fiberglass, it's silica or quartz or ceramic, and they're all in the same group. There are two classes of fiberglass. There used to be two in the National Toxicology Report. There are still two classes of fiberglass, microfiber and larger diameter industrial, over 3 micron. Well, everything that we work with is 6.5 to 9 micron. Anything under 3 is respirable. If it's respirable, doesn't mean you can inhale it into your lungs. It means it can get into the pores of your lung tissue because it's small enough to get into your tissue. I think we're on our 17th US toxicology report, and last year when that came out and I read it, I noticed that they didn't separate the two classes of fiberglass as they used to, and they have lumped them into one category, fiberglass. And they removed the word respirable and replaced it with the word inhalable. So we put Proposition 65 warning stickers on every product that we make, whether it goes to California or not. And we say, this could be dangerous, it could hurt you, don't breathe it. Here, read the SDS, they're on our website. my board of directors was a little concerned that I was going to do this, and I had to explain to everybody in the plant why we're doing this. And they said, well, customers are going to get nervous. And I said, well, we'll deal with them one by one, but I'm looking out for the company. Well, why do you think you need to do this? I said, because in a court of law in California, one day, a jury is going to award plaintiff a victory in court and a lot of money because they are going to say that fiberglass causes cancer in humans because this person has it and he has fiberglass in his lungs. There may be a smoker and the cigarette filter is fiberglass, and you can get some of that in your lungs from that. How do they get it in them? Who knows? But let's say they get cancer and California says it's fiberglass. Well, all of a sudden, we're going to have the asbestos thing all over again, like Johns Manville and all the large corporations go in Chapter 11. My strategy is develop a new product, and that is this aerogel, high temperature aerogel product that can be cast, injection molded, coated, extruded, skived, all the different manufacturing processes for liquids, and make non-fiber seals for all of the fireplaces and all of the aircraft. And this ceramic fiber not only goes into ceramic matrix composites, but it goes into the window seals, door seals, thrust reverser seals, engine cowling seals. But if everything's hazardous, what are we going to do? So that's why I'm developing new non-fibrous materials, flexible refractory composites, I'm calling them. And I'm filing for patents for those and trying to stay ahead of my competition.
You're not going to allow what happened to the asbestos industry happen to you, essentially.
That's what I'm trying to do. And at the same time, be proactive, forward thinking, develop products that are substitutes that will also command a higher price than fiberglass and a higher margin, and corner the market with patents. So looking forward, we'll be heavily into aerospace, but we're going to sell this other material that can be foamed into the aircraft and mass transit, all the trains, buses, in the seating. They use silicone foams, fire barriers under the floors and walls. It's all over, and we're going to, for those industries, price it the same as, or maybe a little higher than silicone foam, but it's a much better fire barrier, lower thermal conductivity, vibration dampener, and sound attenuator. So it's really the holy grail of insulation and safe. So
it sounds like you've studied your markets, which I love to hear that. And the future looks really bright for Mid-Mountain Material. We're at the end of our time, but if you don't mind staying on for a while, then we'll just kind of do more of an informal question and answer and kind of a networking.
Sure.
But I want to say thank you so much for being a member of CAMPS. You guys have participated and been a big part of what we've been trying to do, a great contributor to the overall manufacturing community. And I think we all learned a lot from you today.
Well, thank you. It's kind of a cluster out there in the factory, but
it's how things get done.
Yeah.
It's like real life to me.
Well, it is. Yeah, manufacturing is real life. Machines break.
Things happen. Yeah,
things happen. Right.
Real life. So I'm going to go ahead and stop the recording and thank everybody for being here, and then we'll stay here for some informal networking and Q&A.
Okay, great.